This is four problems from section 8.8 improper integrals that didn't make it into the. I think there's another video that has the other ones from this assignment. So between these two videos, should have them all. I think these might be. I think I chose for the other video the harder ones, so I think these might be quick work for us. Okay, so improper integral, basically the idea is you just do what you know how to do, and then we'll kind of like plug in, quote unquote, that infinity, and if we get something that goes to 0, as this goes to infinity, then we're good. We have an answer. So the antiderivative of this, you could write out a u substitution, but it's just like the constant multiple thing, so if this is just linear in x, then we're good. I like to bring the constant to the outside to factor that out. So negative 1/2 times, this means 1 over e to the 2x, so that's 1 over e to the infinity minus 1 over e to the 0. And this does indeed go to 0. So I have negative 1/2 times negative 1 over e, and that's 1 over 2e. And I cleverly opened up the solution manual here to the right thing, and so I could check my answers as we go. And oh, sorry, that's not e. That's just 1 over 1, not e there. So that's just 1/2. So I can fix little silly mistakes like that. Number 9, we have from negative infinity to 0, 2x minus 1 cubed. So why is this an improper integral, you might ask yourself? Well, that's a good question. Oh, because, sorry, I was looking for a vertical asymptote, but we're going negative infinity here. So that's why. Okay, so what's the antiderivative of this? Again, you could write out a u. I guess we'll write out a u substitution for this one. I think it's possible to do it without writing this out, but certainly more error-prone, and I do not want to make an error. So I'm going to need a 2 on the inside here, which means I need a 1/2 on the outside. And I need to change my limits of integration. So 2 times negative infinity minus 1 is still negative infinity. And plugging 0 in here gives me negative 1. Don't forget that. We have to change those. Now, that means I can rewrite this problem as a u problem and never look back. Antiderivative of u to the negative 3. Bump the exponent up by 1 and divide by the new exponent. So that gives me negative 1/4, going to bring that to the outside, and then I just have u to the negative 2. So u to the negative 2 is 1 over u squared. So 1 over negative infinity squared minus 1 over negative 1 squared. So that does indeed go to 0, so we're going to get an answer. Negative 1/4 times negative 1 is 1/4. And just check that. Yep, we're good. Oop, I was supposed to get negative 1/4. No, I wasn't. Yes, I was. So let's see, what did I do wrong there? Let's see. According to the back of the book, supposed to get I messed up the order of these. Sorry, that's what it is. So those should have been the other way around. Sorry. Negative infinity to 1, so you top minus bottom. And then that would change the sign of that. Okay, fixed. 11. That's pretty good. 2 for 2. Making mistakes. on these ones. That is what you call perfection right there. 2 for 2. All right, see if I can do this one error-free. Antiderivative of that is 1/3 e to the 3x. No funny business necessary. So that's 1/3 times e to the 0 minus e to the negative infinity. So that does in fact go to 0. That's 1 over e to the infinity, and that's 1, so that's just 1/3. And yeah, felt pretty good about that one. 13, how about this? What are you supposed to do with that? The problem here, you might be tempted, you might think about this, or might occur to you now that you could think about this in this way. And so this is like the area from negative infinity to positive infinity under the line y equals x. So it would look like this, but this just bleeds out forever on both sides. So there's two choices here. If we just look at this, the answer to this is either 0 or that it is divergent or does not exist. So which is it? Well, we have to be careful how we define things in this kind of situation. You might be tempted to say, and I think it's pretty reasonable to want to say that this positive infinity cancels out this positive infinity, so the answer is 0. But for kind of technical reasons, we really can't let that happen. So if you're going to have a convergent improper integral, in other words, if you're going to actually get an answer for one of these, then every part of the area that you're finding has to be convergent. You can't have a convergent answer that's made out of divergent pieces. So if any of the pieces of the area, if any of the parts of this integral are divergent, then it's a bust. So this is divergent. So here, because we have, we can't have this double-edged thing, so we could say, for example, you can go from 0 to infinity, and then from negative infinity to 0. You could do those two pieces, and what you'll find, I just have to do one of these real quick, that's x squared over 2 from 0 to infinity. That's infinity squared over 2 minus 0 over 2, and this is divergent. So if any one, you don't even have to do this now, if any one piece of it is divergent, then the whole thing is a bust, which is why we report here that it's divergent. If you said 0 and you were tempted by that, I understand, but we can't let that be our way of doing things, so we don't.